I think the recording has started. Thanks a lot for joining our consultation meeting on the Broadland Rivers catchment, important freshwater area analysis. I am Anglian. I'm working for the Freshwater Habitats Trust as a senior freshwater invertebrate biologist. So, let me share my screen with you. Okay, this is our agenda for today's meeting. We will first have Hannah, who's working for the water resource east, and also we will have Robert to give a welcome introduction. And then Jeremy is our CEO of the Freshwater Habitats Trust. We will share on what kind of analysis we are doing, and also we share our findings for this region. And then we'll follow up by a Q&A session. So I would like Hannah to give a introduction and welcome speech.
Thanks, Alan. Hello, everyone. It's really great to have you on our webinar today. My name's Hannah Gray, and I work for Water Resources East. I'm Programme Manager for Nature-Based Solutions, and we have part-funded this work through our Norfolk Water Strategy Programme. So in case you aren't aware, I should do the bit where I explain who WRE are. So we're an independent, not-for-profit membership organisation, and we're one of the 5 regional water resources planning groups around England. And we have many members, but we also have a board that's made up of the organisations you can see that support our small team to do long-term water resource planning. And the area that I'm involved in is how we can work with natural processes to help us manage some of our water security challenges. One of the things, could you move on to the next slide, please, Alan? Yeah, so one of our flagship programs is the Norfolk Water Strategy Programme, which is a collaboration between ourselves, the Nature Conservancy, Anglian Water and Norfolk County Council. And it's trying to see if there's ways that we can address some of the water security challenges that Norfolk has, which you'll all be familiar with, the pressures on our environment through climate change, pollution, growth, is all impacting us in all the ways that you'll be familiar with. So we're working together to try and find out how we can use nature-based solutions to help us restore more natural processes and deal with some of these challenges. And so we fund various different pilot projects to understand better where those nature-based solutions can be based to have the biggest impact, and also to pilot some of these approaches on the ground. And so we've kind of part-funded this analysis with Anglian Water as well, to understand better where these features could be located in the landscape to have maximum benefits for water and also biodiversity. So I'm going to pass over to Rob. Thanks, Rob.
Hi everyone, yeah, so I'm Rob Cunningham, work for the Nature Conservancy, which is a kind of globally environmental NGO, and we're really pleased to be sponsoring the Norfolk Water Strategy Programme as one of 13 flagship projects around the world. So if you go onto the Nature Conservancy's Resilient Watersheds website, you will find Norfolk alongside the Amazon Basin and lots of glamorous places around the world. And they're all looking at how we use nature-based solutions to tackle water security. And the reason I was really interested in this project and really supportive of kind of investing in it is because thinking about how we use nature-based solutions to improve biodiversity and the importance of understanding where biodiversity exists and where the opportunities are. And so, you know, just as a starting point, it's really important that we kind of recognize the limitations around nature-based solutions. So absolutely, they can bring benefits to biodiversity and bioabundance as a kind of as an alternative to other grey infrastructure solutions or indeed other land uses, but they're not in themselves, if they're trapping lots of pollutants, you know, they are limited in terms of how special they can be. We want to be really clear about, and through our program, thinking about where do we site these things and how do we site them to deliver the greatest possible benefits. So focusing in Norfolk, if we could have the next slide. Alan. So just thinking, and this is really a work in progress. This was something I just kind of pulled together to try and organize my thinking about this around so with nature-based solutions for water quality and water resources is kind of the big focus of the Norfolk Water Strategy Programme. We're also thinking about habitat protection, so areas of existing high quality habitat creation and restoration, and also just thinking about people and how do we bring these different drivers and the different sources of funding together to create a kind of coherent strategy that we can deliver at a landscape scale to really maximize benefit for the different sources of funding that are going into that. So if you just go to the next slide, Alan, I don't want to dwell on this too much, and I just came up with this this idea around in some places that absolutely vital that we continue to protect existing habitats. There'll be places of opportunities where we want to restore, and there'll be places where we can use nature-based solutions both to enable that habitat restoration, but also as part of our wider strategy for protection. And the reason I think this links to this important freshwater areas work is because quite often what we're thinking when we think about nature-based solutions, we're thinking at a really granular scale, and we're often thinking in headwater streams and in areas which in the landscape which aren't really very well reflected in terms of the way that either water quality is monitored or biodiversity is recorded. And Alan, if you want to go to the next slide. So this was me thinking through what might that look like in practice, and this was just a random headwater stream in the Wentham catchment that I had a map for that I could do this. And if you look closely, you'll see a yellow line, and that's the Water Framework Directive water body. The red line is actually all of the stream network that's on the OS 1 to 50,000 scale map, and you can see that actually there's an awful lot of water network that isn't covered by the WFD Water Framework Directive water body. So there's an awful lot of the stream network where actually the very local impacts from PTPs, packaged treatment plants, or septic tanks that are going to be there. The sewage treatment works is 3 kilometers upstream of the Water Framework Directive monitoring point, and there's 5 tributaries upstream that feed into the stream network before you get to the Water Framework Directive monitoring point. And then on top of that, you've got SAC, Special Area of Conservation designation. And so just thinking about how we could use different sources of funding at a very local scale to deliver water quality and environmental habitat benefits, species benefits, at a very local scale, but also then kind of add up to a kind of a regional scale protection around the SAC River. And so this important freshwater area work is really trying to, why I was really interested in it was kind of synthesizing information to help us make the best possible decisions at a local level in terms of targeting and what are the right sources of funding and the right strategies deployed in the right places. And that's all I really wanted to say.
Right, I think that's me for a moment to now. So before we get on to Alan talking about the main detail of the analysis that we've done for the Broadland for the Broadland catchment, I just wanted to say to do 2 or 3 slides just to give you some of the background of where this has all come from, because actually it has quite a long history, and we've been working on this for a while, and it's now kind of reaching a sort of culmination where we're actually launching the concept of the freshwater network formally, officially soon after Christmas. We've been piloting and trialing it in various guises, actually, in effect, and you'll see in these slides, for the best part of the last 10 years, but particularly over the last 5 or 6 years. So the core principles of the important freshwater areas concept has been a thing that FHT has developed with a range of national habitat and species experts, with land-owning organisations and land managing organisations and the statutory bodies. And it actually grew out of something we did quite a while ago, which we started when we were actually still just called pond conservation, in fact. So it grew out of the idea of identifying important areas for ponds, work that we did after ponds became priority habitats in the early but I guess that was post 2007. And we did this analysis out in for parts of England. We did Wales, we did Northern Ireland, and this has grown out of all of that. We did some work in, next slide, Alan. I think I might be actually able to change these on myself, in fact. Anyway, so we did some of this work on the continent as well. So we've rolled this out. We piloted parts of this same important areas for ponds work, from which all of this land, the whole freshwater environment landscape assessment grew. We've done that with the European Pond Conservation Network in the Alpine Arc and the Mediterranean Basin. There's a map there of the Mediterranean Basin where we were identifying just important places for ponds at that time. So there's quite a long history to this. And following those some initial trials we had, including that work, was we had two national workshops back in 2014 and 2016 to develop the methods. We, as FHT, tested the concept some more in two CABA catchments, the River Ock in Oxfordshire and the River Rhine, North Yorkshire, to start introducing the idea to people managing catchments, to the organisations who are running catchments in different parts of the country. We've tried it as well we've piloted two counties as well, Oxfordshire and Buckinghamshire, close to our main base in Oxford, and a range of regional studies. So we've done the Brex, for example. Obviously Nick will know all about that. So we did that with Nick's project on in the Brex. We've done the River Irvine in Mid Wales as well. So we've been trialing out this idea for a while now, and are beginning now to roll it out a bit more nationally, and are now on the cusp of preparing to do that across the whole country, essentially. And that work, just to be acknowledging people's support, that work has been funded by Natural England, by the CABA National Support Group, who've paid for some of it, and by a local charitable trust close to us here in Oxfordshire, which has helped quite a lot, called the Patsy Wood Trust. And what we're doing with this approach really is it's about helping everyone, a bit like Rob was saying, really, a bit like helping everyone who's involved in managing fresh waters to provide a basic plan that can help people to protect freshwater biodiversity as a whole, bringing together, I guess really what we're doing is bringing together the nature and the water sides of information and approaches to fresh water, which can be a bit separated at the moment, just because of the way we have the way our policies are operating. And Alan will come on in a moment or two to a bit more detail about the freshwater network, of which the important freshwater areas are a key component. I think that might be, is that my last one, Alan? Have we got one more after that? I'm handing over to you now, aren't I?
Thank you, Jeremy.
Yeah.
So I just want to add a little bit more of background about why we are doing the freshwater, this kind of work. Pond, I would like to choose ponds as an example. Pond is a very important freshwater habitats with exceptionally high biodiversity. According to the Countryside Survey conducted some years ago, they find that the number of ponds in the Great Britain actually has dropped significantly since the 1900s. And there are many other studies try to estimate the number of ponds, and they all come up with some very varying figures that about, according to the latest review on the roles of agricultural ponds, about 50% of the ponds has gone in the UK in terms of numbers. But of course, ponds can be lost or recreated. So obviously we can altogether create some more ponds that can create more habitats. The implication of losing ponds or the degradation of ponds actually can affect biodiversity. According to a study conducted by our colleagues from Freshwater Habitats Trust together with their research fellows, they found that this is relatively recent figures, roughly about 1% of regional plant diversity decline recorded in some agricultural catchment. And the problem is even more serious for the rare species. And we all know that fragmented habitats with small population can also have higher species extinction rate. So if we can connect freshwater habitats, make it wider, wetter, and also cleaner. That would be a way to stop and reverse the decline of freshwater biodiversity. And we think creating a freshwater network can help to protect our precious resources. So we obviously we need to find out where to put those networks, how to link the habitats together. And we believe that building the network around existing freshwater biodiversity hotspots or restore some of the degraded habitats can help. And as a start, actually, we first look into the entire UK to find out where will be the location with clean water and also with higher richness in terms of freshwater organisms. And in the UK, we have identified 24 what we call important freshwater landscape. And the Norfolk and Suffolk area actually contain 2 important freshwater landscapes, including the bricks area. As Jeremy mentioned, we have already conducted an IFA analysis for the bricks, and now we are going to present a study around the Norfolk and Suffolk Broads. But we are not just looking at the Broads; we are looking at the entire Broadland River catchment. As Jeremy briefly mentioned, we have started this kind of work for a while, and we have done a number of IFA analysis for a number of catchment across the country, mainly around Oxford, but we also have some study, for example, in Yorkshire and Wales as well. If you're interested to look at the report for the bricks, actually here I've provided the link. You can take a look of the bricks report, which published a little bit earlier. These are some of the maps extracted from these reports. As you can see, the sort of outcome of the report actually is look like this. So we've highlighted certain area important for the freshwater biodiversity. The major objectives of our analysis is to use existing information to identify where the location with high quality of freshwater habitats, and also with more concentration of what we refer as species of conservation concern. I will tell you a bit more what do we mean by that. The report can also help us to have a more focused approach to do restoration in the region, and also to support the planning of conservation works in the project area. And we also hope to find out the gaps or the knowledge gaps so that in the future we can prioritize the resources to find out which area should worth more study. This is a schematic diagram to show the general approach of the IFA analysis. Basically, we will try to collate species as well as habitat data together so that we can find out which areas is important. Let me talk a bit more about the details. We have some criteria. Those criteria was developed together with some national experts and also with our research partners. So the first important criteria is the water-dependent designated sites. So those sites, they should be sort of having national status. So for all those nationally designated sites, they would automatically included as important freshwater areas. You may want to know how about those locally important sites if, for example, they fulfill the following 2 criteria. If the location is a biodiversity hotspot based on the species of conservation concern in 1 km square, and also it has the presence of restricted SOCC, restricted species of conservation concern. What we mean by that are those species with restricted distribution. I will talk a bit more details when I explain what we mean by SOCC. Apart from species, we also would consider the habitat data. So a area included in IFA should be either having high particular directed biological animal status, or is a kind of priority habitats, or habitats of principal importance related to freshwater, or is a location with high concentration of clean water. Then, if they fulfill both of these species and habitat criteria, then they would become an IFA. We acknowledge that we only base on existing data available, so there may be areas that are important, but we may not have enough data. So we also accept some advice from experts who are familiar with the region. So these are basically the criteria for us to conduct the IFA analysis. Let's focus back to the Broadlands River catchment. I guess all of you should be quite familiar with this catchment. It's quite a large catchment with more than 3,000 kilometers square, with the majority of the catchment located within the Norfolk, while only part of the River Waverley catchment is located within the Suffolk area. This map is generated from the data conducted by Jeremy together with his research colleagues. This map shows the major water environment in this catchment. The blue color represents the rivers or the river floodplain, and also some low terraces. And we have some lakes and the Broads area together, and also showing some location that particularly at the lowland region and around Broads is full of alluvial deposit. If you take a brief look at this map, you may find that it seems the northern part of the catchment seems a bit more wet when compared with the southern part around the River Waverley catchment. You may recall that one of the criteria which is very important for us to determine the location of IFA is the where would be the nationally designated sites. And in here, we mainly refer to the SSSI and also the Ramsar site, which is the wetland of international importance, also the National Nature Reserves, the SAC and SPA. So for the entire catchment, actually, it has more than 100 SSSI in the location, but we have excluded those sites, for example, only important for geological reasons. And in here is showing an example how we determine a site, whether it is water dependent or not. Basically, we would look into the details of the SSSI citation, as well as looking at the priority habitat maps produced by Anglian, so that if we find that the SSSI or this designated site include some freshwater habitats, then we would consider it's a water-dependent designated sites. As if we look at the Broads and marshes, for example, it's quite a large area, and actually it's contained quite a lot of freshwater habitats within this location. Some smaller sites that may be having less number of habitats, but they're still water dependent. When we put this designated site in map, we actually find that many of the sites actually have multiple destinations. For example, many SSSI around the Broads, they're also Ramsar site. or having other destination as well. So we've got this layer showing the location of designated sites. We also try to put the location of priority habitats as well as the what we call habitats of principal importance onto a map. In here, we can see that actually there are quite a lot of important habitats around the box as well as the entire catchment. As you can see that, for example, if we look at the green lines here, they are mainly the trout stream system, which is a priority habitat. We also have priority ponds or priority lakes as sort of scattering around the catchment. And certainly some of these catchment has higher numbers of priority ponds. But I would like to stress that it may not include all the ponds of conservation importance. So, but it gives us some important information about the existing location that those important sites where they located. We are interested in the Water Framework Directive ecological status. When we are looking into the water bodies, we try to look at whether it has a ecological component, such as invertebrate, fish, or the plants. Plants being referring to those high plants like the macrophytes and the phytobenths. So we have found out which water bodies with these high ecological status in terms of one of the ecological elements. I've mentioned species of conservation concern a few times. This slide gives you some idea what do we mean by that. They are basically having some conservation status or protected by law in the UK. So they include all these. I'm not going to read through them, but just want to give you some rough ideas that we have about 1,000 species on this list. Apart from the species with specific conservation concern because of the rarity of the climate population, we've also added one group of species, the indicated species, into the species of conservation concern list. For example, the stonewall, which is a species sensitive to water pollution. So we include them so that it may help us to get a better picture about maybe which area has better water quality. This table is included in our report. I think the font size may be a bit too small, but I've highlighted important numbers. Actually, the Broadland River catchment has many species of conservation concern. How do we gather this data? Our main data source actually is coming from the Anglian atlas, as well as the biological record centers of the two counties, including the Norfolk and Suffolk. We also gather data from the Norfolk Beetle Recorder and also from Professor Carl Sayer from the UCL. We've got many number of records, but some of these records may be duplicates, but this does not really matter because what we are interested in is the number of species. So even we have two identical records, but if they are recording the same species, it's the same species. So we are interested in the number of species. And we have one more column, is whether those species is widespread or species with restricted distribution. I will talk about this in the coming few slides. This map gives us an overview on where those species of conservation concern located. As you can see that there are quite a lot of species located around the Broad area. So around for example, the Broad National Park actually has having quite high concentration of species of conservation concern. We can also find many species along rivers as well. You may be interested why certain dots in this map show their spacings quite regularly. Actually, they are spacing about 1 kilometers away from each other. It's because when we select the data, including the analysis, we would try to include the resolution of the geographical location with at least 1 km by 1 kilometer square. Of course, we include data with higher precision on the geographical position. So those dots actually they're having 1 km by 1 km resolution. One more thing to add is that we only include the records between 1988 to last year, until the end of last year, because we want to include relatively recent records of the species in this map. So we are not including records like too long ago. But by just looking at that map may not be very easy for us to interpret. So we convert the data into density of species of conservation concern in 1 kilometer square. So from this map, you may find that certain grid within that 1 km by 1 km area actually can have or support more than 100 species of conservation concern. Some of these grid are, for example, around the ends, forests and marshes SSSI. Actually, many of the grids in this SSSI has more than 100 species of conservation concern. Some area along the river or even in the headwater area, this is the red grave and no fan SSSI. They also have some higher concentration of species of conservation concern. The other thing worth looking is that indeed the entire Broadland River's catchment is sort of covered by this grid. It's somehow reflecting this entire region. Actually, it's quite important because many areas actually are supporting the population of species of conservation concern. However, if we focus on the location that support species with restricted distribution, it gives us a little bit more clearer picture on certain location may be of particular importance. Why it is useful to separate the widespread and restricted species is because restricted species, they may be more vulnerable to local extinction. So we think those areas supporting more or supporting some restricted species actually worth protecting, because if losing their habitat in that particular area, it may mean we are increasing the chance of local extinction. While talking about restricted species may face a problem of local extinction, some widespread species, they also face similar problem. Here is a highlight. For example, the white claw crayfish, which is a widespread species, but unfortunately, if we try to look at it in 10 years interval, we find that around the 90s, actually the white claw crayfish were quite common across the northern part of the catchment. But if we are looking at the more recent records, actually they become very rare in this catchment. So this is basically how we interpret the species of conservation concern, as well as we are having many data sets on the habitats as well. So it's time for us to combine those data sets together. So we have a layer of water-dependent designated sites. With another layer of the priority habitats and habitats of principal importance. We have this map showing the location of restricted species of conservation concern, as well as the location with higher concentration of species of conservation concern with higher density of them. Then we got a very complex picture with many of this information overlaying with each others. The underlying blue patches, as you can see, actually is we're trying to include the location that are fulfilling those criteria. And this map I also remove the grid with the lowest density of SOCC. Okay, as you can see that this map basically the location with orange color. Okay, with those higher concentration of SOCC, somehow have a lot of overlap with the, for example, priority habitats. So after sort of combining these data sets, we have come up with these important freshwater areas in this catchment. There are a total 15 of them, and those areas basically are delineated based on our criteria, but we also taking connectivity of the freshwater habitats into consideration. Also, we think that it may not be a good idea to put an urban area as our important freshwater areas, because at the end of the day, we would like to facilitate habitat restoration. But I will go back to this point a little bit later. Certainly, you can. I believe both of you should get the copy of our report, so you may take a look on each of them from the report. But basically, the IFA has included all the water-dependent designated sites. Some of them with the high WFD ecological element with high status in it. And also the priority habitats. And this map showing the area with the high concentration of SOCC. And also the restricted species. So if you look at this map, you may have a question in your mind, why a certain area, it seems it supports quite a lot of species of conservation concern, but why they are not included in the IFA? This gives you an example. This is the close-up map of the city of Norwich. As you can see that in this area, we've got quite a lot of record of SOCC, maybe in the park or along some river, but it is sort of like surrounded by urban area. So this is the reason why some of these locations are not included. Actually, I've tried to look into what are those SOCC. Many of them in this area actually are records of the Norfolk hawker, which is a dragonfly that maybe the adult dragonfly actually they can fly around this area. Maybe people can record those the dragonfly easily and record them. And I believe a lot of recording program in the area as well. Yeah, so because people interested to protect the species. So when we draw the outline of the IFA, we've tried to avoid some of these urban areas. But in general, we will try to follow our criteria to delineate the IFA. But having said that, the precise delineation of the IFA boundary is for indicative purpose only. So it somehow reflect the site structuring and topographical boundaries. And the exact boundary, is it someone cannot see this line? Okay, so I hope you can see this line. Okay, so and also the for presentational purpose, the boundary are smooth. So if you're really trying to make use of our map, actually we can provide you the shapefile of the location. And so the exact boundary, if we look at the details, it's basically for presentational purpose only. So this is something you may have to pay attention. But if you really want to proceed with some, for example, habitat creation project, you are putting your site within the IFA or adjacent to it, I think it can still help you to think of how you exactly plan your work, depending on the land ownership, etc. So if we look at this map, you can see that actually the location of the IFA helps us to identify where the location in the catchment has more has high priority for projects, for example, habitat creation or habitat enhancement work. And actually, the boundary of the IFA, if you since it's for indicative purpose only, but if you look at their general location, somehow you may also consider that having some sort of work that may also help to link those IFA together. But this is based on the existing information, so those locations are of particular importance. At the northern part of the catchment, for instance, around the headwaters system seems a very good potential for wetland restoration work as well. For example, around this IFA, which is the Norfolk Ponds area, this area actually has a very complex network of chalk stream, together with many priority ponds. Indeed, UCL, they have conducted quite a lot of research project around this region. In recent years, actually, they promote what they refer to the resurrection of ghost pond around this region. So basically, many ponds, as you may recall in some of my earlier slide, many ponds has been sort of lost in this country, and those ponds actually lost maybe during the agricultural intensification process. So it is possible that if we do some restoration work, that those previously filled ponds can be restored with very good outcome. Actually, Freshwater Habitat Trust, we have very good experience in habitat creation. Here, I would like to show you two pictures, which are some examples of the wetland mosaic that we created in different locations of the country. So actually, when we create those habitats, we have built a lot of experience and make some suggestion to pond creation as well. For example, we do not want the adjacent water body that may be polluted, that the polluted water may enter to the newly created pond. So we think that putting the creation in clean water area will be important, and it's also important not to link those newly created habitats to some existing water. Indeed, we have quite a lot of we have summarize some of this experience in some publication, so that when you are thinking about pond creation, you may make reference to some of these information. And indeed, there will be a new guideline being published related to pond creation and management, and there will be a conference next month. No, actually, in very soon. You may be interested to register to our conference. This is called the Pondful Project. Maybe Jeremy can share with you a little bit more about what is it. So under this project, we are going to publish a new updated technical guideline for pond creation and management. One of the areas we consider important is the alkaline fan in this area. We think many of these fan actually are not being managed properly, and that may cause long-term decline in the area. This is an example. If we look at, for example, the Bradley-Moore SSSI, although its overall status actually is favorable, but if we look at the individual features of these SSSI, we may find that the invertebrate assemblage, for instance, actually they may be declining. So it's somehow highlight that we can actually do something to see whether we can fix this situation. Lastly, we think that we should have a follow-up review on the condition of the SSSI and all the priority habitats in the area. And we also think that we should put more focus on the headwater system. As you may recall, actually many areas in the, for example, in the lowland, in the Broadland area, they are already having some good legal protection status. But obviously, that would be important for us to see whether we can spend more resources in the headwater system, for instance. And as Rob mentioned earlier, there are a lot of programs that the TNC, together with the Anglian Water, the WRE, they are very enthusiastic in promoting the nature-based solution in this region. So obviously, it is a very good opportunities for people to work together. Finally, we think that we can do something to maybe take a look on the overall catchment, whether we can do some refinement on our current approaches. Okay, I think that's basically give you an overview on this IFA analysis. So if you have any questions, please feel free to ask.